Hello everyone, welcome to the introduction of the SimCenter transfer function tool. So this SimCenter educational tool aims to help you understand the principle of transfer function and its application to the propagation of waves in one-dimensional layered soils. And this tool demonstrates how to calculate an output or surface motion inducted by a given bedrock motion. This tool allows users to define layer cell profiles underlain by either rigid or elastic bedrock and able to change the properties of each layer, including thickness, shear velocity, density, and damping ratio. This is how the tool looks on the Windows system. Under the Help menu, if you click on Documentation, this button will bring you to the online documentation of this tool, where it shows the theory and background of this tool and also some examples, and also shows how to compile this tool or build this tool if you are interested. Now let's get back to the main window of this tool. So the main window has three parts. On the left, we have the controls for layer properties and also for motion selection. In the middle, we have the plot for the layer. On the right side, there are two tabs. The first tab is the Define Layers tab. It is divided into two parts. The first part shows the tabular view of the summary of the soil profile, the name of each layer, and also the thickness, density, shear velocity, and damping for each layer. And down here is the transfer function evaluated for this whole soil profile. And under the motion plots tab, there are 5 subplots. So from very bottom to top, we have the input motion acceleration time history. We have the input motion for the amplitude transfer function, and the output motion for the amplitude, and then the output motion acceleration time history. So from the first to the second subplot, the fast Fourier analysis was performed to convert the input motion time history from the time domain to the frequency domain. And then the output motion for amplitude is computed by multiplying the transfer function and the input motion for amplitude at each frequency. And depends on the soil properties and the frequency, the output motion for amplitude may be amplified or de-amplified from the input motion for amplitude at different frequency. So at the very top, this is output motion acceleration time history. So now let's get to how to define the layer properties. So if you want to add or remove a layer, just use these two buttons. And if we want to change the properties of each layer, there are several ways. So we can either select the layer in the tabular view, or we can just click on the layer plot. And the select layer is highlighted. And to change the properties, we can just double click on the tabular view and input the number we want, or we can use the control on the left side. You can slide or input numbers here. And if we want to change the motion, we can just select different motions down here in this region. There are example earthquake motions, for example, L central, Rinaldi. They all show different properties like duration or the frequency contents. And there's also harmonic motion. And when harmonic motion is selected, the frequency control is unlocked. So we can change the frequency of the input motion and see how the changing frequency can coincide with the transfer function. There's also frequency sweep. And if you want to define your own motion, it's also can be achieved by using a JSON motion format. And the online documentation shows some example formats that you can use. And if you want to zoom into part of the figure, just select and drag. And then this region of the figure will be zoomed in. And just click on Reset Figures, then all the figures will be restored to its default view. And if we want to change the relative change in amplitudes of the output motion, we can lock the axis. This will lock the limits for the x and the y-axis. And this will show the relative change in amplitudes. And if we want to unlock everything, we can just simply click on the Reset Figures button, and everything will be restored to its default view. If you have any questions or comments, please don't hesitate to contact us. Thank you.